All right, welcome. You know that phrase, right? But it works on my machine. If you've ever said that, or let's be honest, heard it from a coworker, then you are absolutely in the right place. Today, we're demystifying Docker, the tool that set out to make that phrase a thing of the past.
Oh man, it's the absolute classic developer nightmare, isn't it? You spend all this time building an amazing application. On your machine, it's perfect. It runs like a dream. You're feeling good, you're ready to deploy, and then the second it leaves your computer, everything just breaks. So what is actually going on?
So picture this. On your development laptop, life is good. You've got the exact right version of your programming language, the perfect database driver, all your system libraries are dialed in just so. It's this happy, perfectly controlled little ecosystem. And then you push it to the test server, and what happens? Bam! It crashes. Turns out, the test environment is missing some critical library that you installed on your own machine months ago and completely forgot was even a thing. And there's the first crack in the foundation.
Okay, so you finally fixed that, get it past testing, and now it's time for the big show, production. And it fails. Again. But get this, it's for a totally different reason. This time, the production server is running a slightly different version of the operating system, and a core part of your app just isn't compatible. This exact mess is the problem Docker was born to solve.
So what do? Well, the solution isn't to try and make every single server on the planet identical. I mean, that's just a losing battle, right? No. The real solution is to package your application inside its own standardized box, a box that has everything it needs to run, no matter where you send it.
You know, the core idea here is so simple, but it was absolutely revolutionary. The official docs say it perfectly. Docker lets you separate your applications from your infrastructure. What that really means is, your app stops caring about what operating system it's on or what libraries are installed on the host machine. It just brings its entire world with it inside that box.
Honestly, the best way to think about Docker is to look at real-world shipping containers. Think about it. It doesn't matter if that metal box is on a giant ship, a train, or the back of a truck. The box itself is standard, and the cargo inside is safe and sound. Docker containers do the exact same thing, but for your software. It's a standard, portable, and isolated box for your code.
So, how does all this magic actually work? Well, okay, it's not really magic. It's a really clever piece of software called the Docker engine. Let's peel back the layers and see what's going on under the hood.
When you get right down to it, Docker works on a pretty classic client-server model. When you're typing in your terminal, you're using the Docker client. That client then talks to something called the Docker daemon, which is this background process that's doing all the heavy lifting, building your apps, running them, and managing everything. The whole flow is actually pretty straightforward. You type a command, like docker run. Your client zips that command over to the daemon. The daemon gets the request and says, okay, what do I need to make this happen? If it's missing a piece, it'll go and pull it from a registry, like Docker Hub. Once it has everything it needs, it builds and runs your container. Simple, but incredibly powerful. Okay, to really get Docker, there are two concepts you just have to know inside and out: images and containers. They are the absolute heart of how all this works.
Let's start with the simple view. Just think of a Docker image as the blueprint. It's the master plan, the detailed recipe that lists out everything your application needs to run. The code, the libraries, the system tools, the environment variables, all of it.
Now for the pro view. Technically, an image is a read-only template, but here's the really brilliant part. It's built in layers. Every single instruction in your blueprint creates a new layer that sits on top of the last one. This is huge, because when you change just one line of code, Docker only has to rebuild that one tiny layer. That's what makes Docker images so unbelievably lightweight and fast. Okay, simple view again. If the image is the blueprint, then the container, well, that's the actual house you build from the blueprint. It's the real, live, running instance of your application, happily chugging away inside its standardized box.
And now for the pro view. A container is a runnable instance of an image, and the most important words there are loosely isolated environment. This means the container has its own private world, its own file system, its own network, its own processes, all completely walled off from the host machine. That isolation is the secret sauce that guarantees both security and consistency.
Okay, theory is great, but let's make this real. Let's look at this one single line of code. It's one of the most common Docker commands you'll ever see. We're just telling Docker, hey, run a new container based on the Ubuntu image and give me an interactive command line inside it. So what actually happens when we hit enter?
So when you hit enter, a ton of stuff happens in like a split second. First, Docker checks if it has that Ubuntu blueprint on your machine. If not, no problem, it just goes out to Docker Hub and pulls it down. Then it creates a brand new container from that image, slaps a writable layer on top so you can make changes, sets up all the networking, and finally runs your command. And just like that, you are sitting inside a clean, isolated Ubuntu environment. It's pretty amazing.
So, we've come full circle. We started with that classic problem, it works on my machine, and we've dug into images and containers. But what's the actual payoff here? Why did this technology completely transform how we ship software?
So why does any of this matter? Well, it all boils down to a few massive wins. First, you get fast, consistent delivery. Deployments become predictable, not a roll of the dice. Second, your apps become incredibly portable. The exact same container can run on your laptop, in the cloud, wherever. Third, they're way more lightweight than old-school virtual machines, so you can pack more apps onto the same hardware, which saves money. And finally, that isolation we talked about gives you a huge security boost.
And that really brings us to the end here. Docker fundamentally solved this huge, nagging problem of portability and consistency. By creating this universal shipping container for code, it completely unlocked the modern era of cloud computing and microservices. So the question it leaves us with is a big one. If your code can truly run anywhere, and your imagination is no longer limited by the machine it's on, what becomes possible?